1, I'm going to explain the concept of differentiation and the main rules used to find derivatives. Differentiation is a process in calculus used to measure how a function changes with respect to a variable. It also represents the gradient or slope of the tangent line to a curve at a particular point. The derivative of a function is defined using the first principle of differentiation. This formula shows the instantaneous rate of change of a function as the change in x approaches 0. These are the four main rules to find derivatives. Power rule states that when differentiating x raised to the power n, we multiply by the power and reduce the exponent by 1. For example, the derivative of x cubed is 3x squared. The product rule is used when two functions are multiplied together. Meanwhile, the quotient rule is applied when one function is divided by another function. The chain rule is used when a function is inside another function, also known as a composite function.
We are going to find the derivative dy dx for the function y equals to ln x cubed sec 2x. Step 1. Identify the rules and split the equation. Looking at this equation, we can see that it's produced of two different functions, a logarithmic function and trigonometric function. This means we need to use the product rules, which is u v prime plus v u prime. First, let's break down the differentiate each part separately. This gives us 3x squared divide x cubed. Simplify the down, we get 3 divide x. The derivative of sec theta is sec theta tan theta. Don't forget to multiply by the derivative of the inner angle, which is 2. So our v become 2 sec 2x tan 2x. Step 2. Combine using product rules. Now we have all our pieces u, u prime, v and v prime. We just substitute them into the product rule formula. Plug in and we get it. Step 3. Rearrange and finalize. Finally, let's clean up the expression to make it neat. We bring the constant and simpler term to the front of each part. Our final derivative is this. And this is the final answer for part A. Moving on to question B. We want to find the derivative for the fraction function y equals to 3 minus x squared divide e tan x. Step 1. Identify the rules and split the equation. Because the function is written as a fraction, we must use the quotient rule, which is vu prime minus uv prime divide v squared. Let's identify our numerator u and denominator v and find the derivative. Our numerator is u minus x squared. Differentiating this is straightforward. The constant 3 becomes 0 and x squared becomes negative 2x, so u prime is negative 2x. Our denominator is e tan x. To differentiate an exponential function, we copy the function as it is and multiply it by the derivative of its exponent. The derivative of tan x is sec 2x. Therefore, v prime equals e tan x sec square x. Step 2. Apply the quotient rule. Now, let's substitute these terms into the quotient rule formula. Step 3. Factorize and eliminate. This looks a bit messy, but notice that e tan x appears in both terms on the top. As well as in the denominator, we can factor it out from the numerator to cancel it out. Factoring out e tan x from the top gives us, we can eliminate the e tan x on top with one of the powers in the denominator. Then, step 4. Final rearrangement. To match our final handwriting step, we can expand the negative sign or rearrange the numerator term beautifully. Let's group the sec square x term first. Turning the minus into the distributive property, like this.
We move on to question number 3. Question number 3, given 3y square plus ln x over y square plus sin e to the power of x minus 2x equals to 10. Alright, so as you can see here, x is tangled up with y, then we can use log's law to separate them. Log's law is ln a over b equals to ln a minus ln b. Alright, then you can label x as a and y square as b, so equals to ln x minus ln y square. Then we differentiate y squared, so we bring power of 2 to the front, so it becomes ln x minus 2 ln y. Alright, substitute them back into the original equation. So 3y squared plus ln x minus 2 ln y plus sin e to the power of x minus 2x equals to 10. Next, differentiate both sides with respect to x. So whenever you see there is y term, then you must multiply with dy dx. So here we will use chain rule. Okay, for term 1, 3y squared. So differentiate y squared, it will become 6y. Alright, term 2, ln x, so it will become 1 over x because it's just a standard x. Term 3, negative 2 ln y equals to negative 2y multiply with dy dx. Okay, don't forget that when there is y term, we must multiply with dy dx. Alright, term 4, sin e to the power of x minus 2x. Sin will become cos. When we differentiate sin, it will become cos. So cos e to the power of x minus 2x, then multiply with differentiation of 2x. Term 5, 10. 10 is a constant number. Constant number will always 0. And then we put it together. 6y times dy dx plus 1 over x minus 2y times dy dx plus e to the power of x minus 2 cos e to the power of x minus 2x equals to 0. To find dy dx, we put all the terms with dy dx on the left and everything else on the right. So here, 6y times dy dx minus 2y times dy dx equals to negative 1 over x, negative e to the power of x minus 2 cos e to the power of x minus 2x. So it will become like this. We will factor out dy dx. So we put dy dx at the front. Dy dx in bracket 6y minus 2y equals to negative 1 over x minus e to the power of x minus 2 cos e to the power of x minus 2x. And then we bring this function to the right. So dy over dx equals to negative 1 over x minus e to the power of x minus 2 cos e to the power of x minus 2x over 6y minus 2 over y. Then to get rid of the fractions at the numerator and denominator, we must multiply this equation with xy. So dy dx will become Then here is our final answer.
We will be presenting the solution for question number 4 using the linear approximation technique. Our task is to estimate the value of 7.98 squared minus 1 over the cube root of 7.98. To begin, I will define the function as fx equals x squared minus x to the power of negative 1/3. Next, I will choose our target value, a equals 8, since 8 is the closest perfect cube to 7.98. This gives us a dx or change in value of 7.98 minus 8, which is equal to negative 0.02. Moving on to step 1, we need to find the first derivative of our function f prime of x. By applying the power rule to differentiate fx, we get 2x minus negative 1/3 x to the power of negative 4/3. When we simplify these expressions, it gives us our final derivative formula, f prime of x equals 2x plus 1 over 3 times the cube root of x to the power of 4. In step 2, I will substitute our chosen value, a equals 8, into both the original function and the derivative equation. For f8, we get x squared minus 1 over the cube root of 8, which simplifies to 64 minus 0.5, giving us 63.5. For f prime of 8, we substitute a into the derivative formula. This gives us 16 plus 1 over 48, which equals the fraction 769 over 48. Finally, in step 3, we apply the linear approximation formula. Lx is approximately fa plus f prime of a times dx. By substituting all our calculated values, we get 63.5 plus 769 over 48 multiplied by negative 0.02. This gives us 63.1795833. As requested by the question, we round off the value to 4 decimal places. Therefore, our final estimated answer is 63.1796. That's all for question 4.